This video is about identifying key information from a problem-solving question and solving modeling problems involving trigonometry. So first skill that you need to know is how to find the maximum and minimum value of trig functions that have been obviously transformed. So here, y is equal to sine 2x minus 1. It's just a translation and a stretch in the x direction. So the maximum and minimum of the sine graph have not changed. So the maximum would be 1 and the minimum would be minus 1 because it's just a translation in the x direction and a stretch in the x direction. So really the maximum and minimum has not changed. Okay, for the second one, this part, cos half of x does not do anything to the maximum and minimum, but the minus 3 at the beginning stretches the y values by minus 3, which means the maximum will now be 3 and the minimum would now be minus 3. Okay, in the cos graph of the third one, again, this part does not change the maximum and minimum because it's affecting the x coordinate. The only part that does is the adding of the minus 5. So that means the maximum would be now, instead of 1, it'd be 1 take away 5, which is equal to minus 4. And the minimum will be, normally it's minus 1, but when you take away 5 from minus 1, you get minus 6. Okay, so the next one, if you look at it again, the things inside the bracket affect the x, so that does not affect the maximum and minimum. The first thing that happens is we times the maximum and minimum by minus 2. And then because it's a positive 7, then we need to add 2. Okay, so first timesing by minus 2. So CBAD tells you, from previous lessons tells you, you do the A first and then the D. So that means the maximum will be, so normally the maximum is 1. So if I do 1 times minus 2, so normally the maximum is, so for this part, let me just say it again. So for this part, the maximum would be minus 2, minimum would be minus 2, and the maximum would be positive 2. So when you add 7 to both, that means the maximum would be 2 plus 7, which is 9, and the minimum would be minus 2 plus 7, which is 5. Okay, next one, tan x. Now tan x, remember, this affects the x, so that's unrelated, as in it doesn't change the y value maximum and minimum. Now the thing about the tan graph is, remember, it goes from negative infinity to positive infinity. So if you times by half and then add 3, so times by half first and then add 3, it doesn't really change the maximum minimum. It's still going to go from positive infinity to negative infinity. It's just going to be a stretch and a translation, so it doesn't change anything really. Okay, y is equal to sine squared x. Okay, remember sine x goes from positive 1 to negative 1. So when you square numbers between minus 1 and 1, you're always going to get numbers between 0 and 1. So when you square numbers between minus 1 and 1, you're going to get numbers, all positive values that are greater than or equal to 1, so greater than or equal to 0, but less than or equal to 1. So between 1 and 0. So that would be the answer for that. So you need to be able to do this because sometimes they might ask you, find when this function reaches in maximum. So this is a key skill that you need to work on. So let's go through a modeling question. Okay, the cabin pressure P in pounds per square inch on an aeroplane at cruising altitude can be modeled by the equation P is equal to 11.5 minus 0.5 T minus 2, where T is the time in hours. So in hours, since the cruising altitude was first reached, and the angles are measured in radians. Now the first thing you should do is, if it's highlight what the angle is measured in, and always change your calculator to that mode. So this is radian mode. State the maximum and minimum cabin pressure. Okay, so first thing we know is sine of T minus 2. If I look at the minimum and maximum, because the T minus 2 does not affect obviously the range, so the y values, that means the minimum is minus 1 and the maximum is positive 1. If I multiply this by minus 0.5, then all that happens is the minimum and maximum get times by minus 0.5. So they do the negative 0.5 will be the minimum and positive 0.5 will be the maximum. when you do 11.5, so I'm doing one step at a time, 11.5 take away 0.5 times sine t minus 2. All I need to do is, because it's positive 11.5, is I add 11.5 to the maximum and minimum. So when I add 11.5 to the minimum, I get 11. When I add 11.5 to the maximum, I get 12. So that means the minimum is equal to 11 per square inch, and the maximum is equal to 12 per square inch. Okay. It says find the time after reaching cruising altitude that the cabin first reaches the maximum pressure. So the maximum pressure was 12. So that means I need to equate the equation, which is 11.5 minus 0.5 sine of t minus 2 is equal to 12. Now I need to rearrange it. Now if I take the 0.5 sine t minus 2 to the other side, it becomes positive, and then if I take the 12 to the other side, it becomes negative. So I get 0.5 sine t minus 2 is equal to 11.5 take away 12. So that means 0.5 sine of t minus 2 is equal to minus 0.5. If I divide both sides by 0.5, I get sine of t minus 2 is equal to negative 0.5 divided by 0.5, which is equal to minus 1. Now I need to do a substitution. Let u be equal to t minus 2. Then sine of u is equal to negative 1. I need to adjust my range. So here my t is always time is obviously greater than or equal to 0. It's always positive time. So that means t minus 2 is greater than or equal to minus 2. So that's my range. So when I find u, I'm doing inverse sine of minus 1. When I do inverse sine of minus 1, I get 3 pi over 2. Okay, now I need to check if this is the first time, obviously it's within my range. So 3 pi over 2, remember, so if I draw the sine graph here, it makes sense. This is 3 pi over 2, so 3 pi over 2. I have to go to the previous one and see if that one is within my range. So this one is obviously minus pi over 2. Is minus pi over 2 greater than minus 2? Minus pi over 2 is a minus 1.5 something. So yes, that is correct. So this won't be the first time. Minus pi over 2 will be the first time that it reaches maximum. So u, remember, was t minus 2 was equal to minus pi over 2. So substitute that for your t. So t will be equal to minus pi over 2 plus 2, which is equal to 0.4292 blah, blah, blah. Now I need to, obviously this is in hours, isn't it? Measured in hours. So I need to find the first time after reaching cruising altitude. So if that is in hours, which doesn't make much sense. So what I would do is convert it to minutes, because it makes more sense when it's converted to minutes. So if I times it by 60, I get t is equal to 25.75 minutes. So 25.75 minutes after reaching cruising altitude, the cabin first reaches the maximum pressure. So that would make more sense than leaving it as it is. Okay, let's do C now. So C, calculate the cabin pressure after 5 hours at cruising altitude. That means T is equal to 5. So I need to substitute that into, substitute T equals 5 into P. Then P will be equal to 11.5 minus 0.5 times 5 take away 2. If I input that into my calculator, I get 11.42944, which is equal to 11.43 measured in PSI. Okay, part D. Find all the times during the first 8 hours. Let me just make it a bit bigger. Find all the times during the first 8 hours of cruising that the cabin pressure would be exactly 11.3. That means 11, so the equation 11.5 minus 0.5 sine of t minus 2 is equal to 11.3. If I rearrange it, if I take negative 0.5 sine t minus 2 to the other side, it becomes positive. And then if I take 11.3 to the other side, I get 11.5, take away 11.3, which means 0.5 sine of t minus 2 will be equal to 0.2. If I divide 0.2 by 0.5, I get sine of t minus 2 is equal to 0.4. Let u be equal to t minus 2, then sine of u is equal to 0.4. So now I need to adjust my range because I've done a substitution. So because t is, they said, during the first 8 hours, so they said the first 8 hours, t is between 0 and 8. So t minus 2 will be between 6. If I subtract 2 from both end points, then I get t minus 2 is between minus 2 and 6. So u is between 6 and minus 2. Should written u is greater than or equal to negative 2 there. Okay, so to find u now, I need to do inverse sine of 0.4, which is equal to 0.4115. So again, this is a sine graph, so I'll just draw my sine graph here. Okay, so this is 0.4415, sorry. If I want to find the next one, I do pi take away 0.4115. So this is pi take away 0.4115, which is equal to 2.7301. In order to do the next one, this one, the same thing as 2 pi plus 0.4115, but that's going to be greater than 6, so that won't work out. To find this one is negative pi take away 0.4115. Again, this one will be less than minus 2, so that one won't work out. So these are the only two values, which means t minus 2 is equal to 0.4115 and 2.7301, which means t is equal to 2.4115 and 4.7301. And this is in terms of hours. So if I want to convert it to minutes, all I need to do is times, so it's 2 hours, 0.4115 times 60, so just that part times 60, the decimal part times 60, I get 25, rounded to the nearest minute. This one must be 4 hour, again here, this part only I times by 60, so the decimal part. When I do 0.7301 times by 60, the number I get is rounded to 44, so 4 hours, 44 minutes. Next question. The variation in depth of water in a rock pool can be modeled using the function y is equal to sine of 30 times t, where t is the time in hours and 0 is less than equal to t, which is less than equal to 6. Sketch the function for the given interval. So normally, I would have, t going this way and y going this way. Now I know sine of 30 times 0 would be 0, so start off from the origin. What I know is also when t equals to 6, when t is equal to 6, 30 times 6 is sine 180, sine 180 is 0 as well. Okay, and also I know that when t is equal to 3, it's going to reach a maximum of 1 because sine of 90 is 1. So what I can see clearly is you're going to get this curve. The other way of thinking about it is equal to, so this is y is equal to sine of 30t degrees. So it's in degrees, don't forget it's in degrees, and t is in hours. Okay, so let me just highlight degrees. Okay, the other way of thinking about it is y is equal to sine 30t is a horizontal stretch by scale factor 1/30. So that means that when obviously when you had this sine graph that goes through 180 like this, now 180 divided by 30 would be 6. So now we'll go through as 6. So that means that will be at 12. Yeah. So it's a stretch factor. It's a horizontal stretch by scale factor 1/30. So you're expecting that shape. B, if t is equal to 0, represents midday, during what times will the rock pool be at least half full? That means the function sine of 30t degrees will be equal to a half, which means 30t will be equal to inverse sine of a half. Inverse sine of a half. So if t is going between 0 and 6, then 30t will be going between 0, 6 times 30 is 180. So all the values between 0 and 180 were inverse sine of a half. So the first value would be, when you put inverse sine of a half into your calculator, you get 30 degrees. So 30t is equal to 30 degrees. And if you think about the sine graph, then if this is 30, then that part would be 150. 180 minus 30, which is 150 degrees. So if I want to find t, is 30 divided by 30, and 150 divided by 30, which means t is equal to 1 hour, and it's 5 hour. Okay. A series of sand dunes has a cross-section which can be modeled using a sine curve of the form y is equal to sine 60x degrees, where x is the length of the series of dunes in meters. Draw the graph of y is equal to sine 60x for 0 is less than or equal to x, which is less than or equal to 24. Okay, so y is equal to sine of 60x degrees is a horizontal stretch of y equals sine x by scale factor 1/60. 1/60. That means when I draw the normal sine x graph, you know it goes like this. So this is y equals sine x. It goes from 0, this is 180, and this is 360. All the x-intercepts now will divide by 60. So 180 divided by 60 means it's going to go to 3. And then 360 divided by 60 is 6. And then it's going to repeat itself. So that means the graph will look like this. So if I draw from 3 is 3, 6, 9, 12, 15. Oops, it needs to be more longer. 18, 21, and 24, where this is x and this is y. And maximum is 1 and minimum is -1. Then it starts from 0, goes through 3, goes back up at 6, so on, 1, 2. So you're going to have, sorry, it's a bit of a stretch, but you know what I mean. They're all maximum at 1. I'm not happy with that sketch, so I might want to draw it out again. That's because, let's try again. I made the space between each one too long. And this was x. So if you think about it, there's 4. It's repeated 4 times. Okay, that's A done. B, write down the number of sand dunes in this model. What I can see is I can see 4 complete waves between 0 is less than or equal to x, which is less than or equal to 24. Therefore, false tangents, because it's measuring the cross section. So if it goes back to 0 after negative, then it must be 1 complete tangent. Give one reason why this may not be a realistic model. So if you can look at the, obviously the maximum y, which is the maximum height reached, then it's all the same, which is unrealistic. So the height of each dune is unlikely to be the same. Okay, next question. The angle of displacement of a pendulum theta at any time t seconds after its release is modeled by theta, which is 0.03 times cos 25t, where all angles are measured in radians. So in radian mode now. State the maximum displacement of the pendulum according to this model. So I know, first of all, if I have cos of 25t, so the minimum and the maximum. Cos of 25t is just a stretch in the horizontal direction, so minimum is -1, maximum is +1. So if I times it by 0.03 cos of 25t, then that's outside the bracket, which means the y is affected. It's a vertical stretch by 0.03, so the minimum now would be -0.03 and 0.03. So this is the answer we're looking at. So a maximum displacement is equal to 0.03 radians, because it's measured in radians. Okay, B. Calculate the angle of displacement of the pendulum after 0.2 seconds. Okay, so if you're doing it at 0.2, substitute t equals 0.2 into theta is equal to 0.03 cos of 25t, making sure you're in radian mode. So 0.03 cos of 25 times 0.2, which is equal to 0.008598, blah, blah, blah. I round it to the nearest, so 3 significant figures, I get 0.00851. Again, because it's theta we're measuring, it's measured in radians, so the units are radians. C. Find the time taken for the pendulum to return to its starting position. So if it's a starting position, we need to know what value it takes when theta is 0. So when theta is equal, when t is equal to 0, not theta, when time is equal to 0. When t is equal to 0, theta is equal to 0.03 cos of 25 times 0, which gives a value of 0.03. So we need to find the next time we get a theta value of 0.03. So we need to equate 0.03 cos of 25t to 0.03. If we divide by 0.03, we get cos of 25t is equal to 1. So if I do that means, it's because it's quite easy, I won't do the substitution. So 25t will be equal to inverse cos of 1, which means 25t, because t is always positive, t is greater than or equal to 0. That means the first time we get inverse cos of 1 is at 0. And the next time would be at 2 pi, and so on. Now, 0 obviously is not the one we want, because 0 divided by 25 gives you 0, which is at the starting point. So it's not the starting point. We want the next one, which is 2 pi. So t will be equal to 2 pi divided by 25. Now, 2 pi divided by 25 is equal to 0.251327. If I round it, I get it's 0.251, and it's measured in seconds, so it's in seconds. Okay, D, find all the time. So I'm going to do D here. Find all the time. It's last space, but I'll do it here. Find all the times in the first half second of motion that the pendulum has a displacement of 0.01 radians. That means the equation must be equal to 0.01, so 0.03 cos of 25t must be equal to 0.01, where t has to be greater than or equal to 0 but less than or equal to 0.5. Okay, which means cos of 25t is equal to 0.01 divided by 0.03, which is a third. Okay, so that means let u be, could just do a substitution for this one because this one's a bit more complicated. Let u be equal to 25t, then cos of u is equal to a third. So if t goes from 0 to 2.5, then 25t will go from 0 to 0.5 times 25, which is 12.5. So u will go from 12.5 to 0. That's the range. So u is equal to inverse cos of a third. If cos u is equal to a third, u is equal to inverse cos of a third, which means I get, the first value I get on my calculator is 1.2310. So this is this cos graph. So the cos graph goes like so. Okay, so I got 1.23, oops, undo. I got the first value, which is 1.2310. So if I want to get the next one, it's 2 pi take away 1.230. 2 pi take away 1.230, which is 5.0522, which is within my range. To get the next one, I do 2 pi plus 1.2310, which gives me 7.5142, which is within my range. To get the next one, I have to do 4 pi take away 1.2310. When I do 4 pi take away 1.2310, I get 11.3354, which is okay. If I go to the next one, it is 4 pi plus 1.2310, which is outside my range, so that's not included. Okay, and this was all equal to u, which is obviously 25t. So in order to get t, I need to divide by 25. So divide by 25. When I divide by 25, I get 0.0492 as my first value, 0.2021, second value, 7.512 divided by 25 is 0.3006. And the last one, 3354 divided by 25 gives me 0.4534. These are all in seconds, so I should say seconds, 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 and seconds. Okay, the temperature of an oven can be modeled by the equation T is equal to 225 minus 0.3 sine 2x minus 3, where T is the temperature in Celsius and X is the time in minutes after the oven first reaches the desired temperature, and the angles are measured in radians. So make sure you're in radian mode. Okay, so first thing, find the minimum. So let's write minimum and maximum. So when it's sine of 2x minus 3, that is a horizontal stretch and a horizontal translation, which only affects the x. So that goes from -1 to 1. When it's minus 0.3 sine of 2x minus 3, all the y values multiply by minus 0.3, so the minimum becomes minus 0.3 and the maximum becomes positive 0.3. It's 225 minus 0.3 sine of 2x minus 3, then you need to add 225 to this. So the minimum is minus 0.3 plus 225, which is 224.7, and the maximum is 0.3 plus 225, which is 225.3. So we're looking for the minimum temperature. So minimum is equal to 224.7 degrees. B, find the times during the first 10 minutes where the oven is at a minimum temperature. So if it's a minimum temperature, that means I need to equate the equation, which is 225 minus 0.3 sine of 2x minus 3 to 224.7. Okay, that means when I rearrange it, I get 0.3 sine of 2x minus 3 is equal to 225 take away 224.7, which means 0.3 sine of 2x minus 3 is equal to 0.3, which means sine of 2x minus 3 is equal to 0.3 divided by 0.3, which is 1. So let u be equal to 2x minus 3, then sine of u is equal to 1. So we have x is between 0 and 10 because the first 10 minutes. So that means 2x will be between 0 and 20, and 2x minus 3 will be between 17 and minus 3. So u is equal to inverse sine of 1. The first time that it is 1 is pi over 2. If we go forward, remember the sine graph repeats as though every 360. So if this is pi over 2, the next one will be 5 pi over 2, which is in my range. The next one will be 5 pi over 2 plus another 2 pi. So keep adding 2 pi, which is going to be 9 pi over 2. The next one will be 13 pi over 2, but it's outside our range. The one previous to that will be minus 3 pi over 2. Minus 3 pi over 2 is obviously less than minus 3, so it won't work out. So that means 2x minus 3 is equal to pi over 2, 5 pi over 2, and 9 pi over 2. So to find out x, all I need to do is add 3 to each value and divide by 2. Which gives me x values of 2.2854, 5.4270, and 8.5686. Those are measured in minutes. But if I want to change them to minutes and seconds, that means I just need to multiply the decimal part by 60. So I get 2 minutes, 0.2854 times by 60, rounded will give me 17 seconds. 5 hours, 0.4270 times by 60, rounded gives me 26 seconds. And 8 hours, again 0.5686 times by 60 gives me 34 seconds when it rounded. See? Calculate the time when the oven reaches a temperature of 225.2 degrees. So that means equate the equation to 225.2, which means 0.3 sine of 2x minus 3 is equal to 225 take away 225.2, which means 0.3 sine of 2x minus 3 is equal to negative 0.2, which means sine of 2x minus 3 is equal to negative 0.2 divided by 0.3, which is negative 2 over 3. Let u be equal to 2x minus 3. Then sine of u is equal to negative 2 over 3. The only condition we have is x is greater than or equal to 0, which means 2x is greater than or equal to 0, which means 2x minus 3 is greater than or equal to, minus 3. Which means u is greater than or equal to minus 3. So u is equal to inverse sine of 2 over 3. We just need it greater, so we need it greater than or equal to minus 3. So when we input that into a calculator, we get minus 0.72 0.97. Okay, we want it greater than or equal to -3, so we want to see. So somewhere here, this is negative 0.7297 for the sine graph. So y is equal to sine x. So I need to find this one, which is equal to pi minus pi add 0.7297. So if I add that up, am I getting a number that is greater than -3? I do. I get minus 2.4119. And that's the last one that can be obviously greater than -3. So we don't want this one, we want that one. So we got 2x minus 3 is equal to negative 2.4119, which means x will be equal to minus 2.4119 plus 3 divided by 2, which gives us an x value of 0.2941. If I times by 60, this is in obviously minutes, which is not very clear. If I times by 60, I can get it in seconds, so I get 17.6 seconds. Okay, last question. The temperature Ft degrees Celsius of a building is modeled by the formula F of T is equal to 16 plus 4 sine 15t, where T goes from 0 to 24, where T is the number of hours after midday. So number of hours is in degrees Celsius. State the maximum and minimum temperature of the building according to the model. So minimum and maximum, then I know sine of 15t, because the 15t does not affect the y, it goes from -1 to 1. 4 sine of 15t multiplies all the y coordinates by 4, because it's a vertical stretch by scale factor 4. So it goes from -4 to 4. And then 16 plus 4 sine of 15t is a vertical translation up by 16. So -4 plus 16 gives me 12, and 4 plus 16 gives me 20, which means the maximum is equal to 20 degrees and the minimum is equal to 12 degrees. B. Find the times to the nearest minute when the temperature is equal to 17 degrees Celsius. So 16 plus 4 sine 15t must be equal to 17, which means 4 sine 15t is equal to 17, take away 16, which is 1, which means sine of 15t is equal to 1 divided by 4. Okay, so if 0 is less than or equal to t, which is less than or equal to 24, sorry, I didn't write that right. If 0 is less than or equal to t, which is less than 24, then if I multiply everything by 15, 24 times 15 is 360. So 15t can go from 0 to 360. So 15t is equal to inverse sine of a quarter, which means when we put this into our calculator, we get 15t is equal to 14.4775. So if you think of the sine graph, because our 15t goes from 0 to 360, this is 14.4775. So if I want to find this one must be 180 take away 14.4775, which is equal to 165.5225. All I need to do is divide by 15 to find t. So t will be equal to 0.9652, and this is measured in hours. And 165 divided by 15 gives me 11.0348 hours. So t will be equal to, if I think about it, because it's measured t number of hours after midday, so that means it's 0.9652 hours after midday. So it'll still be 12. I need to times the 0.9652 by 60 to see how many minutes it'll be and round it. which gives me 12:58. So 12:58 after in the 24-hour clock. And the next one will be, because it's 11 hours after midday, 11 plus 12 gives me 23. So it must be 23. If I do 0.348 times by 60 and round it, I get 2, which means it's going to be 02. So you can either think of it as this in 24-hour clock, or you can think of it as 12:58 p.m. and 11:02 p.m. So those are the two answers.